So this is a continuation of our guided notes. So we're just looking at the frequency distribution table, just to kind of remind ourselves how to actually use this. Thank you for the reminder. So you should be able to note the class width, like I said before, lower limit of the second class minus the lower limit of the first class. We can write that here, formula for class width. So lower limit of the second class minus the lower limit of the first class. You can find the class width by finding the difference between those two. Your class midpoint, that's another formula you should know. Class midpoint. And this is when you take the lower limit and the upper limit of the same class and you divide by 2. So lower limit plus upper limit divided by 2. Both from the same class. Good. And then I would just recommend practicing making frequency distribution tables. You probably have this down pat already, but it might be a good idea just to, play around with this. We have histograms. Just being able to read histograms is really important. You can practice this in the homework, or you can redo the notes essentially and see how well you do. Consider we're just reading the histogram, so we'll be able to answer all these questions without any issues. I think one of the questions that tends to be marked incorrect is the idea of finding the percentage. Remember that percentage is found by taking part over total and multiplying it by 100. Okay, so if you wanted to know, look at this, approximately what percentage of admission tickets are at least 23? At least 23 means 23 or more. So you're going to add up these 3 columns because we want to go from 23 or more. So 4 plus 1 plus 2, that's going to be 7. That's your part, right? The successful outcomes out of the total. And then we have to figure out how many admission tickets or how many parks there were total. And then you simply do the math. So just be really careful. I've found students get this wrong more often than not, which is a bummer, especially since it's very easy to find percentage. You just do part over total. Okay, good.
I have a question. I think I saw an error on there. Can you go back up?
Sure.
It says for number 2, 17, shouldn't it be 7 over 17 instead of 7 over 19?
Oh, this guy. So for this one, let's see, the total was going to be 9, 10, and then plus another 9. So it is 19.
Oh,
Yes.
okay.
I think it's because of number 2. So number 2 said approximately how many admissions tickets cost less.
Oh, okay.
Yeah.
I just looked at it really fast.
That's okay. That's okay. It's good for us to just double check and make sure that everything is on the up and up. So yeah, that was only referring to the first four bars, not the 5th. Good. Very cool. I would definitely recommend going through those. You're not going to see any questions that say, hey, what kind of shape distribution is this? You should know the properties of your skewed left, skewed right distributions. That's not here. So I would actually advise you to not even spend too much time on, hey, is this a normal distribution? Is this a J shape? Is it skewed to the right? That's too basic of a question to get for your part 1 of your final exam. So I wouldn't worry about that whatsoever. Any questions on that so far? And let me stop screen sharing just so you can see what I've written for units 1 and 2. Good. All right. We're all in agreement. Let's take a look at unit 3. For unit 3, we are referring to describing, exploring, and comparing data. So this is all the good stuff, right? So measures of central tendency. I want you to be very comfortable with, so let me write measures of central tendency and that's things like mean. How do you find the mean? Can you just shout it out?
Is it by adding all the classes, everything together and then dividing by the total?
Yes, by how many you have? Yes, absolutely. Add up all of your data values, divide by the number of values you have. So technically we can write the formula for calculating the mean. You simply add up all your values and you divide by however many values you have. N is the number of items in your data set. Perfect. We have the median. How do you calculate the median? Someone else.
List all the values from least to greatest, and then like go from outward, like go in, like cross out to get the median.
Yes,
Well,
to find the value in the exact
yeah, middle.
middle. Perfect. Arrange values and then find exact middle.
But if there's like two that are in the middle, kind of, then you take those two values and add them together and divide by 2.
Perfect. Yes. If there are two values in the middle, you must average them. Very, very nice. We also have the mode. Someone else who can tell me what the mode is.
The number that's used most often.
Yes, exactly. The mode is the most occurring value. So mode is most occurring value. You can have more than one mode. You also can have no mode, right? So those are possibilities as well. Good. We also have something called the mid-range. Your mid-range formula, I've only seen a couple errors with this, so just be really careful. Mid-range, think mid, you're finding an average. Well, how do you find the average? You add values and you divide, right? So the mid-range is your lowest value plus your highest value divided by 2. That is how you calculate the mid-range. You want to add the low and the high, and then you want to divide by 2. Good. And that essentially covers your measures of central tendency. What is going to be really helpful for you to remember is going to be this chart that I'm going to share right now about your distribution. So check it out. We have skew to the left, skew to the right, and we have normal skew. Remember where your mean, your median, and your mode are. So we know that the mode is the most occurring value, which obviously is going to be the peak of the distribution. What we learned and we talked about many, many times is that the mean is super sensitive to outliers. So it makes sense that the mean will be pulled in the extreme values. So for negatively skewed or skewed to the left, that mean is being pulled towards the left, which we would interpret to mean that the average, the mean, is a smaller value than the median. For a skewed to the right distribution or positively skewed, the mean is being pulled towards the higher values. Those are technically your outliers. So the mean is being pulled towards those extreme values, which implies that the mean is a greater value than the median. So I would definitely remember those two key features for negatively and positively skewed distributions. Okay. Just remember the mean is very sensitive to outliers, so it would be pulled in the direction of those extreme values. We have measures of variation. For measures of variation, you have the range, which is simply found by taking the high value and subtracting the low. We have variance and standard deviation. So I want you to consider the process of finding the standard deviation. We did do that once by hand, and then you did it a couple times in your homework. I don't anticipate putting a question that asks you to calculate this by hand. But you should still note that variance has a notation S squared, where standard deviation is simply S. And this is for a sample, right? Which means we understand, by the way, let me put in your population parameters. We understand that if we wanted the standard deviation, but all we had was the variance, we would have to take the square root of the variance to get the standard deviation. Okay, you square root the variance to get the standard deviation. Or if you had the standard deviation and you want the variance, you simply square your standard deviation to get the variance. That's the relationship between those particular values. Good, I'm trying to see what else. This is how we did it by hand. Empirical rule. I don't think you really need to draw the empirical rule. You'll have that. All right, Z-score. We definitely need the Z-score formula. So here we're in measures of relative standing in box plots. I would note the Z-score formula. So Z is equal to X minus, now the mean can be a sample mean or a population mean. So it really just depends on what we're looking at. So I will write mean, and then I'll write over standard deviation. I'm not going to use the particular notation, as you can see here, because the formula will not change. It's just the notation that changes. So hopefully you're all okay with that. We definitely want to make sure we're comfortable using the Z-score formula for standardizing values. Range rule of thumb. Range rule of thumb. At this point, I know a lot of you already know this because we've had to use it again and again and again. Does anyone know how to find the minimum for your range rule of thumb and your max?
Mean
No.
minus 2 times the standard deviation and the mean plus 2 times the standard deviation.
Perfection. The mean minus 2 times the standard deviation, the mean plus 2 times the standard deviation. That's exactly correct. So obviously the smaller one is going to be your minimum. And the larger one is going to be your maximum. Very nice, Suruji. And thank you for joining us despite, feeling pretty crappy. Good. Definitely practice calculating the range rule of thumb. We also are familiar with percentiles and quartiles. So percentiles and quartiles. I urge you to look back at calculating the quartiles. Remember, for the quartiles, you are going to divide your data set into 4 equal parts. You start off by arranging all of your values. And I'm going to just note what page this is from. So this is your unit 3. These are unit 3 notes. Page 16. Yes, page 16. For quartiles, you arrange your data from lowest to highest. You cut it in half. That's your median. You cut the lower half in half again. That's your first quartile. You cut the upper half in half again, and that's your third quartile. It's as simple as that. Okay, median, median, median. And it's of each half. So the whole and then each half. We have formulas for mid-quartile and interquartile range. You definitely want to know these. So I'm going to turn the page and start writing on the back. Let me make sure you all can see what I've got here. There we go. So we want mid-quartile. We find the mid quartile by taking the first quartile, adding the third quartile, and dividing by 2. That should make sense. Mid, average, middle, average, right? When you think of finding that middle value, you technically will end up wanting to average those values out. So it would make sense to add the 2 quartiles and then divide by 2. Your interquartile range, this is also known as your IQR. That's simply found by taking your third quartile and subtracting your first. Remember how to read a box plot? Your box plot will always show you your lowest value, your first, your second, your third quartiles, and your highest value. Always, always, always. So just to make sure that we are okay, I'm going to share with you just one image here. Here's your box plot. Your lower value right here at this end, that's your L, that's your lowest value. The first line of your box represents the first quartile. The second line of your box represents the second quartile. The third line of your box represents your third quartile. And then the very end here, this tail, this piece, that value that's represented by being the very last value here is your high value. And that's how you read a box plot. Good.
I have a question about that. And Q2 would be the mean
Q2 is the median.
or the middle, right?
Yes, exactly. Q2, your second quartile, is your median.
Yeah, thank you.
You're welcome. Perfect. Good. And then, of course, I would just review some of these to make sure you're okay. And then we have coefficient of variation. Coefficient of variation. And that formula is taking the standard deviation and simply dividing it by the mean. And that concludes Unit 3. For Unit 4 and 5, we're in the binomial distribution. So we also have probability distributions. Just remember that you know if you have a probability distribution, if the sum of your values adds up to 1, the sum of your probabilities, and if your random variable takes on a numeric value. Okay, that's something to really, really pay attention to. Just as an example, let me share this screen and then Sudhajini, I'll take your question. So for instance, right here, we see that our random variable does take on numeric values 1, 2, 3. But then when we look at their probabilities, if the probabilities do not sum to 1 or as close to 1 as possible, like 0.99 or 1.001 or something like that, then it is not a probability distribution. It must satisfy both of those conditions. Sudhajini, you have a question?
Yeah, and it's not with this, it's off, but I remember it and I don't want to forget. When it comes to rounding, and if it says round to 2 or 3 decimal places, when do we start, like if it's the other one is 5 or above, when do we start rounding? If it says round to 3 decimal places, do we round just the third one, or do we keep rounding after the decimal place?
Okay.
Do you know what I mean? I don't know if I asked it.
I do. So for instance, and I'm going to type something into the chat. If you had 1.2, 3, 5, 9, 8, 7, whatever it is, and let's say that they asked you to round to 2 places after the decimal, you're essentially looking at the 1.23 and saying, can I stay 1.23 or do I have to round up to 1.24? And that depends on the value to its right. So you're looking at the 1.23 and being like, is this okay, right? So you say, oh, well, it says 1.235. So that 5 must mean that I'm actually closer to 1.24 than I am to 1.23.
Mm-hmm. Okay, yeah, and this is a good one. So if it says round to 3 decimal places, this would answer it exactly. That 3, before I round off, I know I have to round 5 to 6.
Yes.
Do I have to round 3 to 4? Do I
No.
round while I'm going, or I'm just
No,
rounding
no, it's
5?
not a trickle down effect. So it's just the one place that's the only thing you look at.
Okay, that's
Okay. Now,
that's
the
where
only
I'm
other
messing
thing,
up.
yeah, the only other difference to this is if that, let's say they want you to round to 4 places after the decimal. You see how 4 places is 1.2359, but the
Mhm.
number to the right is 7. So think of it as it goes from 59 to 60. You're closer to 60. So actually, when you round that to 4 places after the decimal, this 7 turns a 9 into a 10, which
Mhm.
technically means that 59 becomes a 60.
Okay, so that 3 would remain that 3. It wouldn't
Yes.
turn into a 4. Okay,
No,
I've been
no.
making that mistake, and I've been working one problem for like 45 minutes
But hey, now
because of rounding. Yeah.
yes, just be super careful with that, okay?
I have a question.
Yes, go for it.
What's the coefficient of variation again? I don't remember that.
For the coefficient of variation, we're actually not going to use it all that much, honestly. It's just a value that describes your particular sample or population. And to find it, you would literally just take the standard deviation divided by the mean.
So do you think there would be a question like that would ask to find that out?
That might
Okay.
actually be too easy. So probably not, because
Okay.
it's a very simple formula. No, I don't anticipate you having a specific question just on the coefficient of variation. If anything, it might be like, what's your quartiles, what's your mid quartile, what's your interquartile range, and then what's the coefficient of variation? You might have like, an extra thing like, give me a value here. So just in case, I wanted you to have that formula.
Okay.
Awesome. For your discrete probability distribution, as you notice what I'm writing here, I labeled it probability distribution. We have 2 formulas that we need to write down. So the mean, to find the mean, or what we know is the expected value, all you would do is you would take the sum of the products of your raw data value times the probability of likelihood. So that's how you would find the mean for your probability distribution, which again is the expected value. We have a formula for the variance. This is that bigger formula. I would definitely just practice this a couple times to make sure you're okay. So to calculate variance, you're going to follow a very specific formula. So you're going to take the sum of the products of your raw data value squared multiplied by the probability of its likelihood. And then after you sum all those values up, all you're going to do is subtract the population mean squared. That's the formula you're going to use. So if you wanted to see where this was, this is unit 5. Unit 4, 5 notes, so you know how they were combined. So this is unit 5, page 10. I would definitely go to unit 5, page 10, and then take a sneak peek at the chart that we created together and how we constructed everything, how we would write the probabilities of each. We multiplied X times the probability. We squared each raw data value. We multiplied each squared value by its probability, and then we use that data for our formulas. Okay, it's very clear. Everything is very, very laid out here. I would keep that in mind.
Professor,
Yes.
I'm not sure if this is too late for me to ask this question. So when there's values, when there are multiple values on the tables, do we know, like, do we know that they're probability distribution by adding all that and see if they get like 1 as a total value?
Yes, so right here, you would add the probabilities. If the probabilities add up to 1, then it is in fact a probability distribution. But that also means that your random variable has to take on a numeric value. So as long as it satisfies both of those conditions, it is a probability distribution.
Because like, I think it was my second exam. So there was a one question that asked me about if these values are the example of probability distribution, and I add all them up, and then I got like 1.0001, and it still says that this is probability
Yes.
distribution.
Yes, and I would agree with that because you're so close to one. What ended
Yeah.
up happening was there was a rounding error, right? And there's naturally going to be a little bit of error when you round your values. But I don't want you to think that that means it can't be a probability distribution. You're as close to one as you possibly can get, essentially, without actually equaling one. So I would say that yes, that's definitely a probability distribution. And that the only reason we're above it just a tiny, tiny bit is because of rounding.
Okay.
Awesome.
So if
Steph-
it was like 0.998, would it not be one or would it still be?
I would say 0.998 is as close to one as you can possibly.
Okay, I'm just trying to think of all the possibilities, like, because I know 0.999 obviously, but like if it was a little bit less, okay.
Yeah, for sure. Stephanie,
I was just wondering if we were allowed to have scrap paper, like,
of course.
okay.
Yes, you can have all the scrap paper your heart desires.
I didn't know if you had to check that there was nothing in it or
I
something.
do, yes, I do. So that's gonna be a quick thing. You'll just show the camera. You're basically just going to verify that you're by yourself taking your final exam, that you only have your scrap sheets of paper, you have your formula pages and your tables. Calculator, obviously, drink, obviously, writing utensils, obviously, but nothing else. You should not have a cell phone with you. That should be gone. You shouldn't have other people around you. You should be by yourself. All
Well,
that-
if you have people that live with you, like I lived with my parents and my brother.
Right. You want to be in a room where you're by yourself for your final exam. That has to be a possibility, right? That has to be.
Yeah.
It's one day, one time block. They have to be able to respect that space that you have. So
Yeah.
you might have to have a serious conversation.
Because usually when I'm in here doing my homework, they're talking or whispering or something.
Sujani, you don't have to worry about that. Your daughter's not going to give you, your daughter's a little kid. She's not going to give
Oh
you.
yeah, she's only 6.
Yeah. I'm not worried about that.
Okay.
I have a question.
Yes, go for it.
Can we go back to a probability distribution?
Yeah, for sure.
I just had a quick question. Is my dog allowed to be like in the house?
Yes. The reason we advise that nobody else is around is because we don't want you to get assistance from them. Pets are fine, little kids are fine. Okay. Yes, Donna.
Okay, so can you tell me again, because I think I forgot. What does X represent again?
X is your random variable.
Oh, okay, I
It's
see.
what your
Kinda like
value.
raw data value.
Yeah, it's like your raw data value. It actually has a numerical value assigned to it. So just think of when you are given a probability distribution, that X takes on a specific meaning. So in this case, X is the number of tails X is the number of tails up you could get on the 2 coins, right? So it represents a specific value.
That would be kind of similar as N, right?
Yeah, I mean, I guess kind of if you were listing all of the elements of your set of N is just the total number of values you have in your set. So then when you think of your set, you want to think about what's in it. And then the table lists what's in it. You see what I'm saying?
Yeah.
Okay, that's what it's for. You just essentially list what's in it. So in this case, X is your raw data value. That's your random variable, and it takes on the values 1, 2, 3, and 4. So we list 1, 2, 3, 4. Those are the values of X. And then we use our function to figure out the outputs, right? We want to decide the probabilities. What is the likelihood of that particular random variable occurring? Just play around with this, practice. Don't overthink it. Please don't overthink it. It's just X, it takes on a value, and you're just trying to figure out the probability or the likelihood of each of those values. That's it. That's all a probability distribution is.
I have another question. So I have another final, like right before this, and it's on campus. And I was thinking about doing this one at the library. Is that
Yeah, that's
maybe?
cool.
Okay.
That's actually great. It's going to be very peaceful. Yes, I highly recommend it. Very nice. As a reminder, I've said this before, the standard deviation is when you take the square root of the variance. So keep that in mind. That may be something you want to add to your sheet here. If you know the variance is sigma squared, the standard deviation is found by taking the square root of the variance. Just remember, you'll take the square root of the variance in order to make that happen. Okay, definitely look at examples from your notes so that you can be confident answering questions that involve probability distributions. Definitely play around with that. Next, we have binomial distributions, which means we need a formula. So binomial probability function.
I have a question.
Yeah, go for it.
So how many questions exactly will there be on the exam?
Your part one is going to be 20 questions.
Oh, okay. So, and there'll be like a mixture of multiple choice and then fill in the answer.
That, yes, that's a pretty good way to look at it.
Okay.
And what I'm doing right here is I'm just writing out the formula for the binomial probability function. You want to be able to use this formula, you know, with ease. You figure out what your P is, your probability of success. You figure out what your Q is, your probability of failure. And you figure out what's N, right? What's the total number of elements we have in our set? And then we figure out, what am I looking for? Am I looking for the probability of exactly a specific value? Am I looking for at most, at least, right? I want to think about finding those probabilities and then sometimes having to add probabilities together. Now, in your tables, in the set of tables that I've given to you, by the way, if you're not sure where they are, all you have to do is go into Lumen, scroll all the way down. You will see that there is a final exam contents block. When you open this up, you have your Math 160 tables combined, and you also have your course review packet and answer key. Definitely play around with these so that way you can feel a lot better about what you're studying.
And the sheet that you're, sorry, I didn't mean to interrupt you.
Okay.
This sheet that you're filling out right now, I'm completely drawing a blank to what it's called. You're gonna put that on, yeah, your formula sheet. I don't know why I couldn't think of it. It's just one of those days. You're gonna put that on under that section, right?
Yes, I can put my formula page right in here.
Okay, all right, thank you.
You're very welcome. That's a
Hi,
good
Hi, Professor.
Hi.
Can you show, maybe not to everyone, but I'm pretty sure some of us, like, we probably don't know how to do the calculation. Like, I know how to do it if I like go on a Google and type in calculating binomial probabilities. But how would you calculate, like, using your own calculator without using the
Yeah,
Google?
so for instance, let's do this first one. What you're going to do is you're going to take your calculator and you have to identify where you have your combination permutation notes. So for this particular calculator, the TI-30X2S, you'll press PRB. What that will open up is your permutation, that's the NPR.
Okay.
You can see NCR, that's your combination, that's the one you want. And then you see factorial, but that's not the one you want. You scroll, you essentially are going to use the NCR. Now,
Okay.
in order to actually do this using the calculators, and let me clear this out, you're going to start by typing in 23 because you want 23, choose 22, right?
So where do we get the 23 from? I'm
Oh,
sorry.
that's just from the problem itself. Do you see my screen here where I have at least 22 people will have a cell phone? We are told that N is equal to 23.
Oh, N is the random sample. Okay.
Yes, N is the number of values in your sample.
Okay.
Good.
Then 22 is how many you're choosing.
Yes, exactly. So at least 22 means we want the probability of exactly 22 plus the probability of exactly 23. At least
Mhm.
22 means 22 or more. So that's why we broke it down this way. So for this first one, we're going to do 23, choose 22. So you're going to start by typing in 23. You're
Yep.
going to press the PRB button.
Mhm.
You're going to scroll over to NCR and then press enter.
Yep.
And then you're going to type in 22. So this says 23, choose 22. Then you press enter.
So just plus enter, which gives me 23. Okay.
Yes. And now you just type in the rest. So the rest says times 0.87 to the 22nd power. Okay, so times 0.87 to the 22nd power. And then it says times 0.13 to the first power. You don't have to write to the first, but then there we have it, 0.139667303. And in this case, we rounded to 3 places after the decimal.
So will the test tell us like how many decimal places each time? Because I know that like there's
Yes,
these where you round to like 2 decimal places or whatever, and like different things you round to different decimal places.
yes.
But when we're like rounding, should we at least round to like 5 decimal places to get an accurate answer?
That's a fantastic question. When you are looking at intermediate, your intermediate steps, you don't want to round until the very end, right? You want to wait to round to the places that they're asking for to the very end. So any of those intermediate steps, I would do the same thing. I would probably keep like 5 places after the decimal just to try to make sure that I'm as accurate as possible.
Like if it's like the square root of a number and then it's like a long decimal
Yes.
place and
Yes.
then so 5 or so.
Yeah,
Okay.
I would say
Yeah.
that would be the smartest perspective because you don't want to round too much. Then
Yeah.
the answer will be totally off.
Okay.
Can
I
we
will write
use-
it now. Thank you.
Okay.
You're welcome. Stephanie.
I was just wondering, like, let's say you got a number like 1.678 or something, and it told you around 2 places, and you were like off, like you put 1.66. Would you, I don't know, would you have to be on the one that you want, or would you get some points?
Oh, I mean, you definitely get partial credit for that. You
Okay.
definitely would. The system would not give you partial credit. I would have to give you partial credit.
So you would be looking at our
Yes,
test.
yes. Specifically, if you notice that that is something that happened, please email me. The thing that I would really like from you guys, and I want you to hear me, plus this is being recorded. So again, thank you for the reminder. When you are taking your final exam, the 20 questions, I highly advise you to write everything down on a sheet of paper, numbered. Number 1, here's the work. Number 2, here's the work. Some of them don't require the work, but at least you can write down the number and you can say something like answered on the computer or something like that. For the instance that maybe you wrote it down perfectly on your paper, but you typed it incorrectly into the program. That is when you would say, I have the proof. I'm going to scan my sheet and I'm going to send it to you. And I'm going to say, hey, can you please look at number 4? I wrote it correctly on my paper. I just didn't type it into the computer correctly. Can I get these points back? So that's when you use it to your advantage. You writing everything down, you scan that particular image, whatever it is. If it's 1 question, if it's 2 questions, scan those, send them to me and say, hey, can you please take a look at these? Okay.
So we'll be able to see what we got right and wrong
Oh yeah,
right after.
in the grade book. Yes.
Okay,
I have a question.
thank you.
I have a couple hand raised first, Donna. Can I answer
Okay.
Nick's question? And I think
Yeah, sure.
as well. Nick.
Okay, so one question, and I feel like you've answered this before. How long is the exam?
You have a 2-hour window to take your part 1 of your final exam.
Okay, and then another thing is there a unit that is more that you see more dominant than others? in this exam?
Um,
Because I know some exams are like that, some final exams are like that.
Yeah, I
um,
was gonna ask the similar question, like how much like of the exam, like how many questions are allotted to which, like each unit or something?
For the part one, I would say that's actually pretty spread out evenly. I don't think there's a heavier particular, maybe you'll see a couple more binomials, right?
Mhm.
You might see a couple of those together, only because your unit 7, 8, and 9, those long questions, you know how you have those multiple steps and you have to do all those different parts to like complete the problem. That's in your part 2. So if you saw your part 2 already, you see those really bulky questions are there where you have to break everything down in all the parts. Oh, and also, can I please make this announcement? Last year, when I taught this class for the first time and I gave the final exam out, I had students print out that final exam PDF and then write on the PDF, and they squeezed all their answers into the margins. Nope, this year I'm not accepting that. Don't do that. I won't accept it. Okay, that makes no sense to me. Write your answers on separate sheets of paper. You are not trying to see who can squeeze the most information on the tiny, tiny, tiny little space. That's not what I'm looking for. Please don't do it. Okay.
It just doesn't make sense.
Yeah, thank you. It doesn't make sense. And I'm telling you right now, I will not grade it. I will not grade it. I will not accept it. So don't squeeze your answers onto that PDF sheet of paper where there is clearly no room. It makes no sense. Thank you for stating that, Nick.
Are you talking about the part 2?
Yeah,
Of
the
the
part
exam?
2.
Oh, so like do a separate piece
Yeah,
of paper
yeah,
and
don't
everything.
squeeze
Okay.
it in there. Nicole, you have no idea. I've seen students literally squeezing all of their work onto that sheet of paper, and I'm just like, well, why?
Oh my God.
But why? I know there's not a shortage of paper. So please write it on a separate sheet of paper. Okay. Donna, then Leah.
Okay, so my question is, are we going to have any questions that we'll have to use Excel or like the
No,
minute?
fantastic question. No, you will not. You will
Okay.
not. That's too much pressure. No Excel, no Minitab, no binomial calculator online. Everything that you can do for the part 1, you'll be able to do with your tables
Okay.
and your calculator.
Thanks.
Yes, great question. Thank you for asking that, Leah.
Like that kind of answers mine a little bit because my calculator is the TI Inspire. I don't have that other calculator, so I can't really do the binomial calculations on there.
Let me see if I can find it. The TI Inspire has to have it because it's actually way more advanced than mine. So yours somehow
I was looking around, but maybe I just didn't find it, you know?
And by the way, if anyone else knows where to find the combination thing on a TI Inspire, please share with the group. But I will do a quick online search and see what I can find, Leah. But yours is more advanced than mine, so I'm betting anything it has it.
Sounds good.
How
Awesome.
do we read the binomial distribution table right here? I forgot how to read that, like the one that you printed out.
Honestly, you are not going to use that. You're not going to
Okay.
you're not going to need it. You
'Cause
want
I
to.
was like, why is this on here if I thought we would need it, you know?
I have it just in case, and actually it's part of requirements for the course. You should have the tables, which by the way, those are going to change. We're going to start to move away from tables and use more software instead. But don't worry about the binomial table. You have your formula, just use your formula.
Okay, okay.
That's going to be so much better anyways. And you could
And
do
there's not gonna be a probability where it's like, you have to do that calculator thing? Like, it's not gonna be like a really super small probability?
right. It will be a manageable probability that will make sense. Kind of like the ones we did in our notes.
Okay, okay.
Perfect. Excellent question. Lucy, yeah, for your part 1, it's on Lumen, right? So you're going to have your questions in Lumen. You will be on the computer. You'll be taking your exam for part 1 on the computer in Lumen. But you're going to write down all of your answers on a separate sheet of paper, because if you write something incorrectly, but you write it correctly, but you type it in incorrectly, you want to at least try to get those points back. Okay. And yeah, you'll send a PDF just like normal. Leah, Angelica?
Are you able to show us where, like on Lumen, how we would get to it?
Yes, when it's available. It's not available yet.
Okay.
Okay. I already plan on putting it in your final exam contents block. So once it's available, you'll find it there.
So when we're
So it
doing
would
the
be
part,
just like you kind of.
We say that again?
So would it just be kind of like the units, like we just scroll all the way down and then it would be, okay.
Yes, it will be in that final exam contents folder with your other stuff. You'll see your tables combined, you'll see the formula sheet, you'll see your course review packet, and then boom, part 1 of your final exam will be there.
so part 2 of the final, when we're writing our answers on a separate piece of paper, do we just like label number 1 and then we like work out the problem?
Yes.
We don't have to like write down the whole question and
No,
everything
no,
like that?
no,
Okay.
no. No,
Okay.
just your work.
Okay.
Just your work as cleanly as possible, of course, because I have to manually grade all of these. And that's going to take a while. So make sure that it's as clean as possible, right? Number 1, here's your work. Number 2, here's your work. Make sure your name's on the top, and then make sure when you scan it, you make a PDF. Nick, of course, what I'll do is I'll put an upload spot on Lumen where you can upload your final exam into Lumen. If you are still having issues with uploading your PDF, just send it to me directly via email. Okay. I just want it in one of those places, preferably in Lumen. If you can upload into Lumen first, if that's not working, then send it to me via email. Surujini.
When can we start working on the part 2?
That's yesterday.
Okay.
You could have started as soon as I gave it to you.
Okay.
Good. And I actually hope that some of you have already started.
So I have, oh, sorry.
You'll want to move through that as soon as possible.
Wait, it's already loaded?
It's already in your email. I already gave it to you.
Oh my gosh, I'm like well behind.
It's okay. Just make sure you're reading my emails because it has all the information that you need. It's in your email.
Okay, student email, not Roman.
No, student emails, your actual email.
So when
Okay,
is it due on the 20th?
Yes, it's due at the time that the final exam part 1 starts. So this is due Monday, the 20th, right before the start of our final exam.
I have a question.
Yes.
Actually, I don't think, is this appropriate? Like, because I know I emailed you, but do you want us to like maybe talk it after, like, you know, about the exam on
yes.
Friday?
You and I do have to have a discussion. So yeah, we'll wait till after class.
Okay.
Perfect. Good.
I had a question about question 6 of the unit 9 homework on Lumen.
Right.
Yeah, it gives you this population standard deviation, but you're supposed to only be given the sample one. So then I couldn't really do that question.
Use the Z-score formula from the we'll work through that and I'll show you exactly.
Okay. Okay.
Using
I'm confusing myself on which one to use, and then it's like, yeah,
that one is kind of like ooh, this is a tricky problem because we actually do know the population standard deviation. When you do know that, you use the Z critical value. Try just using the Z critical value. I think you're going to be just fine if you do that.
okay.
Cool. Good. Surujini, do you have another question? Maybe not.
No, I forgot to take my hand down.
That's okay.
Sorry.
I got you. Stephanie.
I was just wondering if you grade the Unit 7 application.
No, not yet. Those
Okay.
are not completed yet.
Okay, because it says 0 and made me nervous.
Yeah,
Yeah,
I
no.
meant be nervous too.
I will
I
let you
was
know
like-
when I finish grading it.
Okay.
I just couldn't believe it that my grade dropped like so dramatic. Like,
It'll be okay. Everything will level out. It is 10:07. I would like to continue writing as many formulas as we can on our formula page. What I will do is no matter what happens, I will finish this formula page and upload it so that you have my version, which may not be the only one you want. You might want to, you know, use it to tweak your own, to make it more robust, to, you know, whatever your heart desires. Okay. You will be able to have your single sheet of paper front and back. So load it up. Okay. Load it up. But anyways, let's get back to the formula page. And let's see what else we can actually write on here. So binomial distribution, that's definitely a good one. I would practice calculating binomial probabilities for sure. Under this same topic for binomial distributions, we have the mean and standard deviation. So the mean you'll find by taking your n and multiplying it by the probability of success. And then to find your standard deviation for your population, you are going to take the square root of n times p times q. Okay, that is how you calculate your mean, which is your expected value, and your standard deviation for a binomial distribution. Good. I'm taking a sneak peek at the rest of this, and that concludes unit 4 and 5. That looks good. For unit 6, here we're discussing normal distributions. So we definitely want to be confident using the z-score table, finding the area to the left, finding the area to the right. I would practice, let me say, practice finding areas under the curve. Right, I would practice that for sure. Okay, definitely consider doing that, which includes finding z-scores associated with percentile, finding z-score when you're given the area, right? You find the z-score given the area. So you should be able to use the table to figure that out. There are applications for the normal distribution. Try those out. Let me see what else.
Should we know like the, you know, like the empirical rule or whatever? Or
No,
like the percentage?
no, you don't have to have that memorized.
Okay.
Good. You should understand how to find z-scores related to the middle percentage, like the middle 88%, the middle 90%, the middle 60%. You should be able to calculate the areas on either side, which is actually what we do later on in unit 8. Let's see. And then your sampling distribution of sample means. This may be a good idea to kind of go over the sampling distribution of sample means. Keep in mind, we have the central limit theorem and we have specific formulas associated with that. So you will want to write down the following. So sampling distribution of sample means, and this is unit 6. Page 21. We know that the mean is the same as the population mean. We know that the standard deviation is found by taking the population standard deviation and dividing it by the square root of n. And we also know that the z-score for this is found by taking the sample mean minus the population mean divided by the population standard deviation divided by square root of n. That's going to be really important. You'll know that you're using this particular formula if we're trying to find the probability that a sample mean is within a certain range, right? Or if we're trying to find information about that sample mean. So we will be using this formula. You'll also be given the population standard deviation, the population mean, as well as n. So you'll be given those values. Sometimes you'll be given a z-score and you need to figure out what that sample mean is, or you'll be given the sample mean and you need to calculate the probability, which means you find the z-score, draw it on the curve, and then find the area of the shaded region. Those are all part of that process. So you definitely want to make sure that you're practicing sampling distribution of sample means. Good. That was unit 6. Unit 7, we get into correlation and regression. For correlation and regression, I want you to just be able to look at images and decide, do we have a positive correlation? Do we have a negative correlation? Is it weak? Is it moderate? Is it strong, right? I want you to be able to do those things. You will not have to calculate the correlation coefficient by hand, so you do not have to worry about that. Let's see what other things, because this stuff is on your part 2. You will not have to calculate the line of best fit, but you should know what the slope means and what the y-intercept means. Yes, this other stuff is in part 2. Good. Okay, we only have 1 minute left of class. So I am going to write out any additional notes that I think you may need for your formula page, but honestly, that's actually pretty good. Your units 7, 8, and 9 are all reflected very well on your part 2 of your final exam. And it's because they're so extensive. There's a lot that you're doing with those questions from part 7 or unit 7 to unit 9. So the most you would see from unit 7 is, here are a bunch of graphs. Can you assign their correlations? Right? We've seen those before, the multiple choice matching of which one has which correlation. So I would definitely practice that to make sure that you are comfortable with those correlations. But beyond that, those kinds of questions and how you break that down, that belongs to a part 2. Okay. All right, on Wednesday's class, we will continue by looking at all your Lumen questions. In the meantime, I will answer questions over email, so make sure you're sending me a bunch of those. I know, Leah, you had just sent one, and I definitely want to take a look at what's going on in that particular problem. All right, but we will do that over the next couple of days, and I'll see you all Wednesday for our last class session, which is, again, more review. Bye, everyone.
Thank you so much.
You're welcome.